I am Dr. Shailesh Kaushal, Department of Business Administration, University of Lucknow, Lucknow. Today I am going to explain non-parametric test. So under this non-parametric test, I will explain Kruskul Wallis Test. So as we know, non-parametric tests are assumptions-free test. It means when my data not normal, not homogeneous, then I should use non-parametric test. So the condition of Kruskul Wallis test when we have more than two independent sample. More than two means there may be 3 levels, 4 levels and 5 levels, and more than 5 also. So in this chart we can see the parametric and non-parametric. So today I am going to explain the Kruskul Wallis test. Now the question is, when and why should we use Kruskul Wallis test? So basically Kruskul Wallis test equivalent to the analysis of variance. And what is the condition of analysis of variance? The condition of variance, analysis of variance is when we compare more than two means. It means there are more than two category, like 1, 2 and 3. There are 3 levels. The limitation of independent t-test means we can compare only the 2 category or 2 levels. But when we have more than 2 levels, then we use analysis of variance. Okay, so here we have 3 levels, means levels may be high dose and medium dose and low dose. Okay, and there are 3 categories, and this y, that is dependent variable, and this variable is metric form, and independent variable non-metric form. Okay, so when we want to compare several means, then we use analysis of variance, and before applying the analysis of variance we check the assumptions of the parametric test. Means data should be normally distributed and data should be homogeneous. Okay, if my data not normal, not homogeneous, then what should I do? I should convert my data or my variables into the log transformation, square root transformation and inverse transformation, and then again check the normality and homogeneity of the data. If still my data not normal, not homogeneous, then I will use Kruskul Wallis test. So directly we should not use the Kruskul Wallis test, because when the data not normal, if my data is continuous and my data not normal, not homogeneous, then we should use Kruskul Wallis test. Okay, it is same as analysis of variance. So in this Kruskul Wallis test we compare several median, but here we compare several mean, because in a parametric test we take mean value, and here in a non-parametric test we take median value or mean rank. Okay, now the condition of the non-parametric test, that is Kruskul Wallis test. This is the Kruskul Wallis test. It is a non-parametric test and counterpart of the one-way independent ANOVA. If you have data that have violated an assumption, then this set test can be useful way around the problem. Okay, now this is my case study. In this case study, coffee consumption, So my question is, does coffee consumption affect your heart rate or not? Okay, so here there are two variables. One dependent variable, heart rate score, it is continuous variable. Another independent variable. So we have divided independent variable into 4 categories. Okay, so this is my case study. The case study, you can go through this case study. The scientist had discovered that the caffeine consumption linked to higher heart rate. Researcher took 40 participants and split them into 4 groups that varied in the number of caffeine consumption. The first group was control group. It means we are not giving coffee to the 10 people and we are measuring the heart rate score. And the second group had 1 cup coffee. This is the second group. We are giving 1 cup coffee and measuring the heart rate score. The third group, we are giving 2 cup coffee per day and measuring the heart rate score. And the fourth group, we are giving 4 cup coffee per day and measuring the heart rate score. This is my simple case study. Okay, now we can see this is case study. So there are 2 variables, that is one dependent variable, it may be ordinal or continuous, and X, that is nominal or non-metric. Okay, so here we have divided 4 category. 10 people, no cup coffee per day. 10 people, we are giving 1 cup coffee per day, and 10 people, 2 cup coffee per day, and another 10 person we are giving 4 cup coffee per day. So here what will we do? We will take the median value of the 10 participants and median value of 10 participants and another 10 participants. So here we are comparing the median value. Okay, so this data, it is continuous, but the data not normal or not homogeneous. That is why we are using the analysis of variance. Now, how to develop the hypothesis for the Kruskul Wallis test? So the null hypothesis, the median outcome is the same across all categories. Means median value of there are 4 categories. The one category we are not giving the there are 4 category. This one Y dependent variable. The one category no cup coffee, then 1 cup coffee, third 2 cup coffee, and fourth 4 cup coffee. Okay, so the median outcome is the same, means median of this group equal to this group equal to this group equal to this, all the median values equal more or less. Now alternate hypothesis says at least one pair of median different from each other, either this pair different from this, either this pair different from this, either this pair different from this. Okay, so we develop null and alternate hypothesis for Kruskul Wallis test. Then so I am showing you the data. This is my data set. So we have taken 40 participants in this study. The 10 people we are not giving coffee and we are measuring the heart rate score. So the another group 1 cup coffee heart rate score, 2 cup coffee heart rate score we are measuring, and this is the last, the 10 people we are giving the 4 cup coffee and measuring the heart rate score. This is my data. Now I should check the assumptions of the parametric test because this data is continuous. directly we cannot use in a Kruskul Wallis test unless we know whether data normally distributed or not. If my data not normally distributed, then I can use Kruskul Wallis test. So let's check the assumptions of the parametric test. So analyze, descriptive statistics and explore. So here coffee consumption, it is categorical variable. I am transferring here factor list, heart rate score independent list, and statistics by default, descriptive statistics, we will get the values of central tendencies, measures of dispersion and distribution, and the test plots. So the KS test for normality, KS test, and leaven for homogeneity. Okay, so the normality plots, I am applying KS test, leaven test for homogeneity, and then continue. After continue, okay. Now we check whether our data normally distributed or not, whether data homogeneous or not. Okay, so this is my output. So in this output, the normality, this data is normal, this data is normal, this data is normal, this data is normal, because all the p value greater than 0.05. So data is normal. Okay, and then the homogeneity, this p value 0.001. So this is not normal because p value should be greater than 0.05. Here p value less than 0.05. So data not homogeneous. So this data not homogeneous. So we will apply equivalent to analysis of variance Kruskul Wallis test, because my data not normal, not homogeneous. That is why we are using here the Kruskul Wallis test. You can see. Okay. Now I am applying the Kruskul Wallis test. So I can apply Kruskul Wallis test through analyze, non-parametric test, and I can perform through independent sample also. There are two ways. If I apply independent samples this way, then I do not need to find the post hoc analysis. It will give default the post hoc analysis. Now, so I am applying analyze, non-parametric test, legacy dialog, and k independent sample, because here sample are 4 independent sample. So coffee consumption, transferring grouping variable, define range, so minimum range coding 1 and maximum 4. Continue, heart rate score, transfer into test variable, and by default Kruskul Wallis test, you can see here, and then OK. And after OK, we will see the result. So this is my result. Okay, what does it say? This result, basically you can see this is the mean rank for no coffee, mean rank of 1 cup coffee, 2 cup coffee and 4 cup coffee. And what is the p value? Here p value less than 0.05. It means the coffee consumption increases the heart rate score. Okay, and this is the chi-square value. But we do not know, because there are 4 levels. One is no cup coffee consumption, 1 cup, 2 cup and 4 cup. So this result is saying the coffee consumption increases the heart rate score, but we do not know whether 1 cup coffee increases heart rate score significantly, 2 cup coffee increases significantly heart rate score, or 4 cup coffee. So what will we do? we will do post hoc analysis. But here we cannot do post hoc analysis. So we will perform 3 times Mann-Whitney test. So we will pair 3 pair. So means we now we will apply Mann-Whitney U test. So there is 1 pair. So 1 pair means we are comparing no cup coffee with 1 cup coffee. Second, 1 no cup coffee with 2 cup coffee. And third is no cup coffee with 4 cup coffee. And then we will check the p value, whether the p value less than 0.05 or not. Okay, so we now my data set, I am opening my data set. This is my data. So I am applying 3 times Mann-Whitney U test, analyze, non-parametric test, and legacy dialog, and 2 independent sample. So one is coffee consumption. So I am comparing no cup coffee with 1 cup coffee. Okay, so the Mann-Whitney U test, and okay. Now second time I am comparing the 2 independent sample, the group 1 no cup coffee with 2 cup coffee, and then continue. And the third group, that is the no cup coffee and 4 cup coffee. This is now you can see the 1 cup coffee and 4 cup coffee. Continue, and then okay. Now I am interpreting the result. So here we can see this is the overall result. The first Mann-Whitney test, no cup coffee and 4 cup coffee. So what is the p value? So here p value, it is 0.405, means greater than 0.05. It means the no cup coffee and 1 cup coffee, means 1 cup coffee does not increase significantly heart rate score. Okay, so the second, we are comparing no cup coffee with 2 cup coffee. This is no cup coffee and 2 cup coffee. So what is the result? No cup coffee, this is the p value. Again p value, देखिए no cup coffee and 2 cup coffee, again p value 0.05 greater than. It means 2 cup coffee does not increase significantly heart rate score. Okay, now we compare no cup coffee with 4 cup coffee. So this is the result, the final result. Here we are comparing no cup coffee with 4 cup coffee, and what is the p value? So p value less than 0.05, because p value 0.034. So this is significant. It means if we take more coffee, then heart rate significantly increase. Okay, so this is the one way to explain the Kruskul Wallis test. Another way we can perform, analyze. Here we do not need to do the Mann-Whitney test. Analyze, non-parametric test, and independent samples, and compare median across groups and fields. So coffee consumption, heart rate score here, coffee consumption here in a groups, and then setting. So Kruskul Wallis test, this is Kruskul Wallis test, and multiple comparison, and then run, and after run we can see the result. So this is my result. So what is the Kruskul Wallis test p value? It is less than 0.05. So in earlier case my p value was the less than 0.05, here 0.006, and through this method it is also 0.006. Now I am double clicking, and after double clicking I will get this. So here I can compare. So this is my result. The median value is this, degree of freedom this, and p value 0.05. So I can report this result also, and the independent sample t-test pairwise comparison. Okay, so I am just taking pairwise comparison. So we do not need to perform Mann-Whitney U-test. Okay, so this is pairwise comparison. So now you can see, so through this output, the no cup coffee with 1 cup coffee. So what is the p value? It is the 0.0, greater than 0.05. No cup coffee with, again it is greater than 0.05. No cup coffee with this, the 4 coffee, less than, no cup coffee per, it is 0.074, and to the 1 cup coffee with 4 cup coffee, so here it is the 0.074. So we can show this result also, and these are the sample no cup coffee with 2 cup coffee we can see here, and then the result we can see the heart rate score, median, and this the Kruskul Wallis test. Now this is my original result when I change Kruskul Wallis test. Now again I am interpreting the result. So the no cup coffee with it is not significant. No cup coffee with 4 cup coffee, it is significant. Okay, and no cup coffee with 2 cup coffee, it is not significant. Only this is significant, 1 cup coffee only. Now question is how to report the results. Okay, so this is the how to report the result of the Kruskul Wallis test. So this way heart rate score was significantly affected by coffee consumption, and chi-square, this is the 12.453, and p value less than 0.05, and the results of the Kruskul Wallis test. So post hoc test Kruskul Wallis, 1 cup with no cup, 2 cup with no cup, and 4 cups with no cup. So this is the result of post hoc analysis. So we can report our result this way. Okay, so thank you very much.